Swayam Prabha. Digital India. Educated India.
Okay, so with this we come to lecture 8, which is on network cities, path dependent consequences. So, network cities, we discussed sanitary cities in the last presentation, lecture 7. So, now we will be discussing network cities by mainly focusing on the robust, elaborate networked infrastructures that emerged in these cities of the modern West, and which actually kind of generated path dependent consequences or path dependent implications. Now, path dependent is an interesting concept which is frequently used in the economic history and also in the history of technology, and it implies that a particular path is chosen where certain key technological choices are made, and these technological choices they remain almost irreversible, and they leave little room for maneuver for both urban policy and urban policy or municipal policy and urban development. So, by this I mean the chosen path which is taken, it remains almost irreversible, or it can be changed, little bit of modifications can only be made at great expenses. So, here we are going to see that how network cities generated a path dependent consequences, that is almost irreversible set of urban environmental conjectures and trajectories. So, yes, two major things that we are going to cover here are like this rise of the networked cities in the West, with maybe one or two examples on robust elaborate service schemes, including Bazalgette's sewer scheme, and we would also concentrate on like how these otherwise very meaningful or fruitful engineered solutions which could accomplish the short term agendas or municipal visions and missions actually also kind of generated long term socio ecological implications. So, river Thames, it was becoming polluted, more polluted with industrialization and with mass migration, with the development of with the development of settlements which were occupied or inhabited by vulnerable marginalized communities coming from the suburbs, coming from the countryside. And so, like Thames during this particular time, during the early part of the 19th century, it can be, it could be considered as the largest open polluted drain. The situation became extremely beyond control. The situation went out of control with this particular event, which in history is known as the Great Sting of Summer 1858. So, this particular event, the idea, what happened is that the Thames, it started rotting so much that it became very filthy, and Europe was not, or London was not being able to afford this stench, and it became so filthy that during this particular point of time in 1858, Parliament declared closure of the river Thames for a few days. And so, the Londoners became desperate to come up with a solution, and it was absolutely understood that yes, an appropriate sewerage network or sewerage design or plan was very much was imperative for the city. So, with this, the Parliament also sanctioned and approved grant for the launch of a new sewer network for the city, and Joseph W. Bazalgette, he was chosen as the chief engineer for the London Metropolitan Committee, and he was given the charge to kind of design this this sewer network for the city of London. And this can be considered as one of the grand designs of the 19th century, which was I mean like it was a heavily investment laden plan. Of course, it sought I mean a lot of infrastructural improvements could be sought, and the immediate problem of filth could be tackled to a great extent. And not only that, this also brought physical changes, physical transformation of riverside London and the River Thames. So, with this we this is the map. So, with this we move on to the grand sewer network scheme designed by Bazalgette. So, if you see that here so Bazalgette, the whole system was all about channelizing this raw sewage or channelizing effluent. So, he I mean in this plan you will find like a series of street sewers. So, the street sewers it channelized the raw sewage or the waste, and finally carried the waste to the main intercepting sewers. So, these street sewers or series of street sewers were connected to the series of main intercepting sewers, which carried this effluent to further downstream and to tidal and dumped it or discharge it into tidal Thames, and finally it was swept out to the sea. So, this was the system, and so in this map you can see that and from the map you can understand that in the on the northern bank of the Thames in the eastern side the major outfall work was the Beckton work, and on the southern part on the southern bank it was the Crossness. So, like sewage was stored here for some time, and finally it was dumped or disposed on the outgoing tide. So, this was the system. Yes. And not only like European cities, not only London, but also several other European cities, like for that matter Finland, like Amsterdam, Munich, Berlin, Spanish cities like Madrid, French cities like Paris. So, during this particular period between 1850s and roughly 1870s, 1880s, we find the first modern water and sanitation services being laid out on the cityscapes. So, for example, Tapio Katko, he has done lot of research on Finnish cities, and from Tapio Katko's several papers and works you can find out that how like this first modern waterworks and sewerage services were established during this second half or the early second half of the 19th century. And Katko did a lot of research on the rise of various Finnish cities, modern Finnish cities like Helsinki, Viborg, Tampere and Turku. And one interesting piece of information that we get from Katko's works is that not only to cater to the needs of drinking water supply, but also water was very important, water was needed for firefighting service, because the houses in these Finnish cities were made of old pine trees, and catching fire was a very frequent phenomena in the cities like Helsinki, Viborg, etc. So, Helsinki, for example, in Helsinki by 1876 this city became absolutely network. And as I mentioned in the last presentation as well, that during the initial phase these investments or the designs were made by private companies, but later it was acquired by the public sector, by the municipality. So, initially Helsinki and Tampere, but after that Viborg, Turku, all these cities started getting covered by water and sewerage services. And Viborg is also very important because in 1892 Viborg developed a very elaborate groundwater system, and this was very unique, and this was the first example of an elaborate groundwater system in any European city. And for that Viborg also got a special award in the annual health fair that was held in St. Petersburg. Yes, so there was the rise of the invisible city. So, why invisible? Because a second or invisible city actually emerged underground, a multi-layered complex of infrastructures for the provision with and disposal of basic resources and services. So, city was considered to be the quasi-organism, and this water pipes and sewerage services as the body's blood circulation, enabling the city to function, and also protecting the city from the poison or from contamination generated from its own waste products. But again, as I mentioned, that path dependent results, consequences or outcomes also is very much are also very much part of this story of networked cities, networked cities standing upon networked infrastructures. So, the chosen path almost irreversible, or maybe more slightly modified or modified to an extent at great expenses or great cost. And also there was a change of direction in how cities started managing their resources. So, we would take a look into this now. Yes, so the story is also loaded with backlash boomerang, unintended consequences, unexpected outcomes. So, for example, Edwin Chadwick's Chadwick, he supported rapid removal of human waste, right? But what happened? I mean, in order to do that, Thames became more polluted because lot of human waste finally was getting disposed into the river Thames. So, Chadwick's limited improvements to chaotic sewage and drainage systems, it finally caused more contamination of the river, of the water in the river, and which also exploded the cholera epidemic in London. So, similarly, Bazalgette's plan, it was a fascinating plan. It was no doubt it was an extraordinary feat of engineering, but his plan could kind of put sewage out of sight, okay, and smelling distance, but disposal and dumping continued. So, this reminds me of the book by Joel Tarr. We would discuss Joel Tarr when we discuss urban environmental history in our subsequent presentations. And so, Joel Tarr, he is one of the very renowned urban environmental historians who had worked a lot on history of urban technologies. And so, he talked about this search for the ultimate sink. So, is there any ultimate sink? And the answer is no. So, maybe like Bazalgette's plan was important, and it could really meet or cater to the short term agenda and mission of the municipality, of municipal governance, but disposal and dumping continued, and the search for ultimate stink, it could not come to an end. Apart from that, several other incidents occurred. For example, there is one particular incident of 1878 which is known as the nasty incident of 1878 in history. So, what happened? This you can this is the picture of that nasty incident, and what is this nasty incident all about? So, the luxurious steamer called Princess Alice, it collided with a freighter and sank it sank into the river Thames, and this was near the outfall. So, what happened is that 600 people lost their lives in this incident, and it was found out after thorough investigation that people who actually lost their lives, they died by swallowing or drinking poison or contaminated water rather than by simply drowning in the river. So, this is very, very unfortunate. Waterborne diseases were managed, most importantly cholera, but negative implications also were crafted on the natural environment. So, for example, with the combined modern sewer system, it became absolutely impossible to separate or segregate the more dangerous contaminants before they entered or these entered into the system. Again, what happened is that when these streets were full of rubbish which were organic in nature, it was still all right, but when horses were replaced with motorized traffic or motor cars, the waste or toxic substances like oil, like rubber whereof, like asbestos were generated, and these inorganic or toxic or obnoxious waste it became a major problem, a major crisis for the cities. So, with the collapse of traditional systems of recycling domestic waste, there was a lot of pressure on the urban space and on the lives and livelihoods of urban dwellers, citizens. So, at the input side of the system, effects of water abstraction were hardly considered. We will come to it in the next slide again, and the effects of output side, the disposal of effluent remained underestimated. One has to remember, and this is a strong and an important message that I would like to convey to all of you through this presentation, that you have to keep in mind that networked infrastructures or network cities, these are not only mere technical or physical stories, because they also comprise social and cultural components. So, these changes, the rise of the networked cities also kind of it is embedded with social and cultural processes of adaptation. So, for example, immediately in these network cities, the behavioral patterns of urban residents in the use of resources and disposal of waste changed. So, for example, in Europe, when water was carried by hand from wells, the consumption of water per day per individual was 10 to 20 liters. So, it was 10 to 20 liters per day per person. But when this manual system was replaced with machines. So, for example, when the cities had this sophisticated systems like flush toilets in bathrooms and other electrical appliances like washing machines, dishwashers, etc. So, the domestic water consumption immediately increased to 150 to 200 liters per day per person. So, you can trace a 10-fold increase. This is scary actually. So, you can see or you can notice a 10-fold increase in domestic water consumption per day. So, with lot of implications we can understand. And apart from this, networking also implies complex legal and institutional regulations, right. And like for example, this also determine or govern the relation between supplier and consumer of these services. And for example, these kind of services, they have like high fixed costs and low cost variables. Their economic logic, the economic logic drove managers to stimulate consumption by degressive tariffs. So, by this I mean that the more you consume, the less you pay. So, that is the economic logic, that is the economic rationale on the basis of which this kind of systems actually perform or function. So, if you understand that if like consumption is stimulated through degressive tariff, then it definitely kind of favored high rates of consumption. So, high rates of consumption again it meant that lot of pressure on ecological or so called finite ecological resources against infinite needs of individuals, and again like the ecological footprint of these cities increased like anything. So, again I talked about like Tapio Katko, who has specialized or who has like produced lot of works on the Finnish cities, mainly on the water supply and sanitation services in the different cities of Finland. So, Tapio, this is again from Tapio Katko. So, Katko draws our attention to the pre-networked Finnish cities, where he says that how during the pre-network times all the Finnish women together daily walked the distance from earth to moon. So, this is metaphorical, but one can understand the essence. So, how all the Finnish women together daily walked the distance from earth to moon and back, carrying water from the well to the cowshed and house. So, the kind of attachment they had with water, so that so they could not waste water, and that is why the domestic water consumption rate was so less. It was so less if you compare the domestic water consumption rate in these modern networked cities. So, yes, so we had discussed this path dependent consequences, these unintended consequences on nature. So, how European cities in order to become sanitary cities, in order to tackle bad environment, in order to cope with health, in order to provide a better environment to its citizens, kind of like try to deal with environmental problems and vagaries, but on the other hand how the innovations or the designs that emerged out of this European search for or birth of sanitary cities also crafted severe path dependent irreversible implications on ecology and society at large. So, these are some references. This is Tapio Katko. I would also very much encourage you to specifically go through the works by Dieter Scott, and we have to cover Dieter Scott when we will actually be discussing urban environmental history as an important urban social science framework in this particular course. So, go through his writings, more importantly this article, but also if you can also take a look at least into the TOC, the table of contents of this particular book, Resources of the City. Yeah. Yes. So, to conclude, I would like to say that in this presentation we had covered how robust sewerage technologies for these western cities should be understood as outcomes of sanitary reforms to address issues of public health. The invisible cities, you remember the invisible cities underground. So, not only the visible city on the surface, but also the weirs, the pipes, the networks, etc., etc., the complicated messy structure in the underground, also gives us a feel that apart from the visible cities, there is also an equal or more important invisible component that enables a city to function in the modern or the contemporary times. So, the invisible cities crafted path dependence with long term and large scale implications, and intended and unintended outcomes were generated, shaping further interventions down the line and determining urban environmental or city nature dynamics. So, with this I would very much encourage you to go through the list of references and to understand the city nature relationship not as a linear interaction, but as a mutual reciprocal entanglement across dynamic and evolving sets of variables. Thank you.